Rational expressions. When is it undefined? If we look at a fraction like half and draw it, let's say in a box, well, 2 means I have 2 pieces, and then the 1 means I shade 1, so that's half. Let's say I had 2 over 3. This one says, let's say I have a circle, and I divide it into 3 parts, 3 equal parts, and I shade 2 parts. That'll represent 2/3. But what happens when you have 4 over 0? Well, here it says you shade 4 and you started off with nothing. That doesn't make any sense. This is undefined. And usually when you're talking about fractions, especially rational expressions, when they become undefined, when you graph them, they have an asymptote at that point. But in this case, we want to know, taking these rational expressions. Now, rational expressions are fractions. They just have variables. And here are 3 examples we're going to do. But let's take our first rational expression. And rational expressions, again, are fractions. When is it that all this is undefined? Well, that's easy. We take the denominator, set it to 0, solve it, and x equals 6. So when we plug it back in, let's say we have the original expression, and we plug in 6 where x is, that's going to give you 2 over 0, which is the same idea over here, where this is undefined. So the answer to this problem is 6. 6, when you plug in 6 into the rational expression, that the whole rational expression will be undefined. Let's look at 3 plus x over x squared minus 25. When is this whole expression, rational expression, undefined? Well, we need to focus on the denominator, x squared minus 25. Set it to 0. Here we have a difference of squares. So what that means is that one's going to be positive, one's going to be negative. We take the square root of x squared, that gives you x. The square root of 25 will give you 5. And you take each binomial, set it to 0, and you can do that because of the 0 product rule. Solve for x here, negative 5. Here you're going to add 5. X equals 5. So here you have 2 answers. 2 answers. And if you plug in each answer into the rational expression, it's going to make the expression undefined. Now, one thing about this problem and many of these problems, rational expression problems, 2 things that are pitfalls. 1, undefined. Many students don't know undefined means 0 on the top or on the bottom of the fraction. Or 2, when they see something strange like this, where it's a difference of squares, students forget to know how to factor it. So that's basically the 2 pitfalls. All right, let's do the last one. 5 divided by x squared plus 8x plus 15. When is this whole expression undefined? Not a problem. We take the denominator, x squared plus 8x plus 15, and we set it to 0. And how we're going to do that? Well, we're going to need to factor it. If you forgot how to factor it, just watch the other videos. You'll be able to factor trinomials or quadratics in this case. So this one I'm going to put an x here, an x here. I'm going to put a plus here and a plus there. 15, I can break down 15 into 3 and 5. So 3 times 5 is 15, 3 plus 5 is 8. We take each binomial and set it equal to 0. We subtract 3 here. We solve for x. We subtract 5 here. We solve for x. And again, we got 2 answers. We take each answer, plug it in, and you'll notice that the whole expression, the whole rational expression, the whole fraction, becomes undefined.